All right, so Jenny, we need to look at two different things here in section 2.2 before you come back. And one of them is called a dot plot, and another is called a stem and leaf plot. And these are just ways of charting data and organizing data. We're going to do an activity to begin. You can see in the notes packet that just has to do with forming a dot plot, which is actually very simple to do. You literally would just kind of, draw your axis with your labels. In our case, we were doing the number of pairs of shoes you own. So let's just say that somebody owns like 10 pairs of shoes, and somebody owns 15, and maybe even somebody owns 17. So we would just put a dot for each person that actually falls into that category. So in our case, all we would do is then just put a dot indicating that, okay, we have a person who has 10, a person who has 15, and a person, let's say, has 17. Let's say they were right there. Now, let's say there's more than one person, then we would just kind of put another dot right above it. Just make sure we kind of fit. This is acting up on me. Let's try it down here. There we go. I mean, it's not good, but so these two dots would indicate, oh, okay, this person, two people own 20 pairs of shoes. So let's go to this diagram, which might be a little bit better here. Kind of just talk over some of the questions that we're asking. So first question, if you read through the situation, you'll see that what happened was scientists took data readings at 42 different locations on 2 different streams. And so the first question says, explain what the dot above 12 in the Stony Brook graph represents. And so there's that one little dot there, and what that really represents is that one location, right? One location has a nitrate concentration of 12 milligrams per liter. All right, let's go to number 2. What percent of the nitrate concentration measurement for each stream exceeded 10? So exceeded means obviously we're looking at more than 10, right? So for Stony Brook, looks like we have 2 out of the 42. And so you can go figure out what percentage 1 out of 21 is, but it's roughly a little less than 5. It's about 4.6, 4.7%. And then in Millbrook, we just count the dots up. It looks like we have 3, 5, 6, 7, 8, 9, 10, 11. So 11 out of 42. Again, a little roughly over 25%. So what that tells me and the kind of inferences I want to make from these situations is that it looks like Millbrook has a significantly higher amount of nitrate concentration at more locations. And so if I was an environmentalist or if I was a scientist who studies such things, I might be concerned. I might want to relay that to the town. Hey, this is a stream you need to be aware of, and maybe if you do let people fish there, maybe it's time to just pause that for a second until we get this figured out. So again, these are things they're not going to tell you in the problem, but you can infer from the dot plot. Number 3 says compare the centers of these distributions, and that doesn't mean like right in the middle. It means more like where the median might be. So the Stony Brook medium, about the 21st dot, looks to be, if you count up 1, 4, 5, 7, 9, 14, 15, 19, looks to be right around there. I would say the Stony Brook medium is about 5 milligrams per liter, and I would say the Millbrook median is somewhere around the 8-ish, probably a little bit bigger than that, but we'll just say 8. So again, we can see that half of the locations in the Millbrook stream are above even 8, not just 10, like they had indicated in number 2. And then the question number 4 asks about the variability, right? Well, variability is basically just kind of a reference to the widespread range. In other words, how widespread is it? So what can we talk about with variability here? That the Millbrook has a larger, we'll just say Millbrook is greater than Stony Brook, has a larger variability because it goes from 0 all the way up to 20, whereas Stony Brook is confined to 12 and under. So again, inferences on how to make a dot plot, how to use it. And the next one we want to go to is the stem and leaf plot. Now, on the stem and leaf plot, this is really, again, just another way of maybe identifying some outliers a little bit easier. talks about quantitative data only, so we're not dealing with labels or attributes. And it's actually pretty easy to do. What we do is we create what we call a stem and a leaf. So in this case, let's use a nice good color here. My stem would be all of the beginning numbers of each decade. So looks like in this group of test scores here, I don't see anything lower than 55. So I can start at 5, 60s, the 70s, the 80s, the 90s, and then the hundreds, right? So what you always want to do is you want to give somebody a key. You want to tell them, hey, if I do this, 9 with a line in between the 9 and the 1, that means 91. Okay? So what I want to do now is for my leaves, right, what I want to put here is all the data points on the other digit here. And I want to put them in order. So obviously I have a 55, right? So we take that off, right? Now let's see, I don't have any 60s. I do see a 70. I see a 72 and a 74. So what you're reading in this row is 70, 72, 74. Look carefully here, and I see a 276s. So we have to actually list those twice, and then a 77. Then we go to the 80s. So I have 81, 82, 86, 86, 88, 89. Okay, then we go to the 90s, and we got a 90 here. We have a 93. We have a 95. We have a 98. And we have a 99. And then, of course, we have two 100s. Okay, so that is how we make a stem and leaf plot. And again, what we could do here is we look at just, which categories are most common. Are there any outliers? And in a case like this, I would actually say that there is an outlier. I would say that 55 is an outlier. Whoops, kind of shaded over it there. But yeah, I would say that's something that we want to make sure we catch, we pick up on. Let me just rewrite that. 55 is an outlier. You may hear us talk about the shape of a distribution, and we'll get into that a little bit more this week and next week. But I would say this one is if anything, it's maybe skewed to the left. And what that means is you have the large amount of the data to the right, actually. So if you were asked a question like that, that's kind of how we would classify that. Now, you see something right below this called an extended stem and leaf plot. And so what that means is when we make the plot, we actually use 2 rows for each decade or each set of numbers that we're doing. The reason we do that is because the first row stands for any data that falls between and including 50 to 54. And the second row is anything that falls between 55 and 59, including 55 and 59. And that would be true of the 60s and the 70s and so on and so forth. So sometimes we flesh out the data and give it more detail just so we can understand a little bit more about if there's any trends and things of that nature. So that basically just wraps up the one class that you missed on the beginning stages of 2.2. We're going to do more of this in class and you'll be there, which is good.